Welcome everyone, and thank you for joining early. We'll begin promptly at the top of the hour. Hello everyone, we'll get started in just a minute. Thanks for your patience as I can see lots of people still joining currently. Okay, let's get started. So hello and welcome, and thank you for joining the webinar entitled Sonarqube Advanced Security, a developer-first approach to code quality and security. I'm Andrew, and I'll be your moderator today, and I'm excited to have Manish Kapoor, Senior Director of Products and Solutions, and Lauren Hanford, Product Manager at Sonar, as our presenters today. Today, we're going to cover how Sonarqube's core security features help identify vulnerabilities early, securing first-party, AI-generated, and open-source code, and of course, Sonar's latest advanced security solutions. But before we begin, let's just quickly go over some housekeeping points. So the session will last around 45 minutes and will include a time of Q&A at the end. You're invited to submit your questions at any time during the webinar from now via the Q&A box in Zoom. So don't use the chat box, use the Q&A box. And behind the scenes, we have two panelists joining us who will answer your questions live throughout the webinar. So we have Yassine from our solutions engineering team and Robert from our product marketing team. So they will be busy behind the scenes answering your questions live during the webinar. So do feel free to submit your questions from any time onwards from now and don't wait until the end. The session will be recorded and we will send out a link via email in the coming days with that recording. And just a heads up that we will include some polls during today's webinar, so please do participate. The more people that do, the more interesting the results. And finally, we will pop up a brief survey at the very end, and we do appreciate your feedback on your experience today. So let me now introduce our presenters, Manish and Lauren. Manish is a seasoned technical product leader, currently serving as Senior Director of Technical Product Marketing at Sonar. And Lauren is a product leader specializing in open source software supply chain security, who recently joined Sonar through the acquisition of Tidelift. Okay, Manish, over to you.
Thank you, Andrew. Welcome all. Thanks for joining us today. I'm Manish, and I'm super excited to present the topic of the day today, Sonarqube Advanced Security. Sonarqube Advanced Security became generally available about 4 weeks back in late May. And this is one of the first webinars that we are doing to talk about our core security capabilities, as well as the new advanced security capabilities that we just added to our product. I will start with how we think about code security and our approach to code security as the first topic. Then we'll dive into what is currently available to you as part of core security capabilities within Sonarqube. Next, I'll hand it over to my colleague and friend, Lauren. She's going to cover Sonarqube Advanced Security. the announcement that the offering that we announced a couple of weeks back. We'll do a demo. And then if time permits, we'll also have a Q&A session towards the end. We will also be answering your questions live throughout the session if you post them in the Q&A panel. All right. At Sonar, the way we think about it is our mission is basically helping developers write code that is good, it's reliable, it's secure, it's maintainable. And we want you to build software that is better, right? We provide you with actionable code intelligence, and most of our customers today use our product for code quality, and some of you also use us for code security. But we do much more than that. We actually, surface insights about the code that you're writing or code that is being developed by AI. And we provide you with insights about code quality, about code security, even architectural insights. And now with Sonarqube Advanced Security, we also give you insights about your open source dependencies. So we surface all the intelligence, code intelligence to you as part of your developer workflow that you can review as part of code orchestration, where you basically do a code review and put some governance into play. Things like quality gates and controls that you put in play so that you can take action in terms of the issues that we surface to you. And you are in charge of what you want to do with the issues that we surface, right? So we give you complete flexibility in terms of deciding how you want to operate and how you want to set up your code quality and code security and everything. We do give you a default profiles and things like that, but it's up to you how you want to orchestrate and how you want to manage and govern your action, the intelligence that we provide. And the last part is we also recently added last year code remediation. Code remediation is we just don't find issues for you. We also help you remediate those issues. We also help you fix those issues. So we announced something called AI Code Fix last year, which basically lets you fix the issues that we discover as part of a code analysis. And this, when we talk about fixing, we leverage LLMs to help you fix the issues. This is all about reducing toil for you, helping you resolve issues quicker. We are also coming up with an agentic offering, Sonarqube Agent, in the later part of this month, which will be available as alpha release, which will be again helping you remediate issues that we discover as part of our analysis. Next slide. All right, so let's start with an icebreaker question. I know you are unable to answer this verbally, but think about it. How long does it take for an organization on an average to identify a security breach? Okay, next slide. The answer is 204 days. Can you imagine that it takes more than half a year for most companies on an average to even know that their application has been breached? This is a pretty crazy fact, and this data comes from an IBM research report. You can search it for yourself and find that report. But it's pretty crazy that for more than half a year, we don't even realize that we have a security issue. And this is exactly how we think about code security when it comes to Sonar. Our approach is basically to code security is basically detecting issues early as you can in your development lifecycle. So we'll talk about our approach next. So our approach is basically a developer-led security approach that starts left. Starting left basically means that you can basically start finding and fixing issues as you code, rather than waiting or making security an afterthought. There's a poll that is coming up on your slide on your screen. If you can take a minute to answer that, that will be awesome. We'd love to know how you are using Sonarqube today, and whether you're using us for everything or you're using us only for code quality. I see the results coming in, so thanks for participating in the survey, in the poll. As expected, I think most of you are using Sonarqube for code quality. I see a whole bunch of companies using us for code coverage as well as SAST, which is good. And a few of you are also using us for infrastructure as a code and secret scanning. So let's talk about what we think about code security at Sonar, how we think about it. Code quality equal to code security is how we think about it, right? And if you just ponder about it for a few seconds, it's actually very, very true. Security isn't just about finding vulnerabilities. It is about writing code that is written with some good fundamental practices. It is written with high readability in mind. It is written with high maintainability in mind. It is modular. It doesn't have bugs. Almost every code which results in a security issue is probably a poorly written code. It's bad quality code, and vice versa. Poor quality code will almost certainly lead to security issues, right? So in order to focus on code security, it all starts with code quality, writing code that is highly readable, that is highly modular, that is maintainable. You look at all the dependencies that it is looking at. And if you take care of that, if you take care of code quality, you're automatically addressing code security issues. Next slide. All right, and this code quality equal to code security is further, confirmed by these are just two examples, but there are hundreds of examples like this one. If you think about the heartbleed buffer overflow, it was a big vulnerability that happened because of a buffer overflow condition. A buffer overflow condition can be easily detected by Sonarqube rules, by Sonarqube quality rules, right? So you have quality rules that can catch, memory exceptions, buffer overflows, and these often can lead to security issues. So issues start with basically simple things like, buffer overflow or remote code execution, as in case of log4j or log4shell vulnerability, which was the infamous vulnerability that happened in 2021. All these kind of issues can easily be solved if you do an automated code review through a tool like Sonarqube, which looks at both code quality as well as code security during analysis. So most of you have heard shift left as a concept when it comes to code security. We take shift left a step further. We say start left. Start left is not just about starting it in the IDE, but also more about how you catch and how you fix issues as they are found and discovered, fixing them early, fixing them as part of your developer workflow, fixing the issues as you write the new code is our philosophy here. And that's what we refer to as start left. In here, you see that we have Sonarqube has an IDE plugin that can work with any of your IDE extensions, whether it's Visual Studio Code, IntelliJ, or things like that. And it connects with our server product or the cloud product, which is the Sonarqube server or cloud. So you can start fixing issues where you are in your development cycle, whether you're in your local environment or you're submitting a PR request or you're doing a full branch analysis. We can help you find and detect issues throughout your life cycle of code development, right? We actually also support a little known fact most people don't know, but we also support AI coding IDs like Windsurf and Cursor, which most of you are using today. If you install Sonarqube for IDE and connect it with Sonarqube server and cloud, you can start detecting issues that are being generated by not only by human written code, but also in AI written code. And of course, we integrate with all of the DevOps platforms that are listed there. So essentially, we meet you where you are in your coding lifecycle and help you detect issues and fix those issues as you find them throughout your development process. Next slide. Okay, so let's start talking about a little bit about how we fit in the whole software development lifecycle and where Sonarqube fits in. So we look at it in a holistic way, and this slide talks about code reliability, maintainability, security, and dependencies, right? This is all that is part of code. That is actually what developers are working on building applications. And then there's the runtime security. So we do not play, in Sonarqube doesn't come into picture when it comes to runtime security, as we believe in shifting and starting left. So we help you write code that is reliable, maintainable, secure, And we also, with advanced security, we also make sure that the dependencies that you're using are secure and not vulnerable. You're using the right set of dependencies. Most of the security companies, if you look at them, they either have SAST analysis, secrets detection, CA and SBOM capabilities. Some of them are into ASPM and DAST as well. But none of the security companies like out there, they will cover code security and code reliability and code maintainability. And as I mentioned earlier, reliability issues and maintainability issues are equally important as code security. The two, code security and code quality, are inseparable basically from where how I look at it. Next slide. So let's now talk about what code security looks like at Sonar. And if you can click one more time, Lauren, thanks. So if you look at what you have in your Sonarqube Developer Edition or Enterprise Edition or Data Center Edition, all the commercial offerings that we have, you already have a set of core capabilities that are available within the product. You have SAST analysis, taint analysis, secrets detection, infrastructure as a code scanning, custom security engine configuration that is available only in Enterprise Edition and higher, and security reports that is also available in Enterprise Edition and higher. So those core security capabilities are already available with you, and we'll really quickly talk about each of those things in the upcoming slides. And then we'll jump into advanced security, which Lauren will cover, but it's a new offering which extends support to open source code. So if you think about it, the way we look at it is core capabilities are for your first party code, the code that you write, the code that your AI agents are writing or AI coding assistants are helping you write. It's the first party code, which is all the core capabilities which are already available as part of the app of Sonarqube. Advanced security extends core capabilities by extending the coverage to third party code, open source code, right? You basically have, it includes SCA as well as something we call as advanced SAST, which was formerly known as deeper SAST. Next slide. So if you look at core security capabilities, next slide. So first one is basically SAST, security application software testing. It's basically looking at your source code and detecting vulnerabilities without compiling the code, without building the code, right? So the kind of vulnerabilities that we detect here, this is offered by most of the code security players like Sneak and everybody else. But here we have a broad coverage. We support a lot of languages, almost all the top flagship languages. We also support mobile languages. We also added support recently for GoSAST. So GoSAST is another language which we recently added support for. But here, when it comes to SAST, it's basically detecting issues like authentication issues or encryption issues. The basic core security issues are detected using our security rules that we have provided to you as part of Sonarqube commercial editions. Next slide. So next is taint analysis. Taint analysis is basically taking SAST analysis to the next level, where we look at cross-function and cross-file and cross-framework aware analysis. We do a data flow analysis to detect more complex security issues, things like cross-site scripting, SQL injection, or any of the injection issues that we detect are all detected because of the taint analysis capabilities. We also detect things like path issues and LDAP injection issues. So there's a whole list of complex security issues that are basically data flow issues. By data flow, I mean you have a function calling another function and calling something else. So it's across files, and it is cross-function issues that we discover as part of taint analysis. And again, here we support a whole broad set of languages in terms of our coverage. So we have lots and lots of languages that we cover, as well as frameworks that we cover. So if you're using Spring framework or Node.js Express framework or Django framework, we can detect issues in those frameworks as well. Next slide. Secrets detection. So this is something, as I saw in the poll, not many of you are using our product for, but this is included in your product, right? It is something that you can use today. And one of the differentiators that we have is if you're using Sonarqube for IDE and connecting it to Sonarqube server or cloud, we can start detecting your secrets in the IDE itself. What does that mean? It basically means we can catch and fix issues which are related to leaking secrets in your IDE before they get into the code repository. Before they make it to the GitHub repository or GitLab repository, we are detecting them and helping you fix it. How does that help you? Basically, you're catching them, you're shifting your security detection earlier in the process. And the cost of remediating or fixing a leak secret in IDE is much, much less than catching it and fixing it once it's already gone to the repository. It's already too late. You have to basically redo the whole thing. You have to regenerate the secrets and do the whole do a lot of work to remediate it. So detecting it in IDE and detecting secrets in IDE as well as your PR analysis and branch analysis is something which helps you catch secrets wherever you are in your journey. We have expanded this offering significantly in the latest releases. We can now detect over 300 plus secret patterns with over 248 plus rules for over 100 cloud services and for thousands of APIs. And the best thing is we do all this with less than 1% false positives based on our internal tests. We also have one additional feature on secrets detection, which is called custom secrets detection. Custom secrets detection is a capability that is available for enterprise edition users, where if you're a large enterprise, I'm sure you have some custom secret patterns that you have defined. You can define custom rules and custom secret patterns to catch those, as well as in addition to the 300 plus patterns that we detect out of the box. Next slide. All right. Extending to our core security capabilities, we also have infrastructure as code scanning. Again, this is something not many of our customers are aware of, but if you are using it, we would love to get your feedback and continue to improve this feature. This is all about scanning your infrastructure as a code files. These are basically Terraform files or Helm files or Docker files or Azure Resource Manager files, Kubernetes files, Ansible files, we CloudFormation files. We have support for all of those common infrastructure as a code platform files. And then we scan those and help you make sure the infrastructure that you're building for your cloud native applications does not have any configuration issues or security issues in that. We detect issues like unencrypted file systems, clear text network communication between your infrastructure servers. All those can be easily detected. And if you detect those, you are basically, again, taking a shift left approach or a start left approach where you're catching the issues earlier. Next slide. This one is called Security Engine Custom Configuration. This is an advanced version of taint analysis. It basically extends taint analysis to fine-tune our security engine further, right? So if you are a large enterprise that has your own frameworks, you have your own libraries and own frameworks that you have defined, which are not open source or which are not Spring or one of the well-known open source frameworks, you can extend your custom configuration. You can write a custom configuration where you can define your source and sink and pass-throughs and validators and all of that as part of a JSON configuration. And you can tell Sonarqube, hey, these are my frameworks that I'm using. Please do analyze this framework and as part of your analysis. So we'll go beyond just analyzing your source code as well as the open source frameworks. We'll also look at your custom frameworks and extend that coverage for you to detect even deeper issues. This is available in Enterprise Edition and higher. So if you've not tried it or if you have a need for it, I would highly recommend exploring it. It's pretty powerful capability. Next slide. Okay, so this is, I think, probably my last slide, if I'm not mistaken. Security reports. For all the issues that we discover, whether it's those SAST issues, leaked secrets, taint analysis issues, advanced SAST issues that Lauren will be talking about, or custom security configuration issues, we surface those up and help you find them, fix them. But we also give you a report. And we also map those reports to common standards like CWE top 10, CV standards. We have STIG and CASA reports in the product that you can, run out of the box to see how your security posture is as compared to well-known industry standards. So this is all available to you as part of the core set of capabilities that are available in the product. Next slide. All right, here I'll hand it over to Lauren, and she will take you through advanced security, and we'll also do a demo on after that.
Thank you so much, Manish, and welcome everybody. We're glad you're here with us today and appreciate all the questions that are coming in. So we're going to point a question at you now. We're going to do our second poll here. I would love to know from folks that are here, which SCA solution are you currently using? Or maybe you don't have one in place. I like to get a temperature check on how familiar people are with this type of technology, and certainly how familiar your developers are with this type of technology in their day-to-day. So I see some answers coming in. Looks like we have a fair amount of commercial solutions that are in place. Some folks definitely don't have anything in place yet, and then there's some others coming in. So there may be things that you're using, ecosystem native tools to check, any risks associated with a node package, as an example, or other things in the Rust ecosystem, etc. Great. So it actually looks like we have a pretty good balance here of how people are solving this problem today. The way that we built SCA at Tidelift was very focused on the managerial experience. And one thing I've really enjoyed about the transition into Sonar has been the focus on developer as a key user and that developer experience. So before we get further into SCA and then the demo, I want to talk a little bit about the other piece of what is in advanced security today. What you see here in this iceberg picture is a really great visual representation of how the technology stack sits on both the code that your developers are writing internally, that first-party code, probably some Gen AI code at this point, agents that are delivering items, and then you go deeper into the open source libraries. So open source software is comprising about 80 to 90% of the average modern application these days. Oftentimes managerial folks can be surprised to learn how much of their code base is really relying on these third-party packages. But what we're delivering today in advanced security is an extension of how we're thinking about our approach to static analysis. And I love this illustration here. It shows how, not only analyzing the first-party code, but going deeper into how that first-party code is using third-party open source at a functional level really helps companies manage risk much better. You understand the quality and the security of your software end to end. It's taking something that traditionally has been very opaque and making it visible. Again, this is critical information for both risk management and ensuring that you're working with higher quality open source libraries. Software is now a connected supply chain, if folks are familiar with that phrase. And so I love how this diagram illustrates that really clearly. You can see here, there's a real world finding where we found something that ended up being assigned a CVE identifier, and it was a critical vulnerability. What this advanced SAST is capable of doing, though, is finding things that may not have been marked as vulnerabilities yet. They may not have a CVE identifier yet, but the risk there could still be just as important as anything that you're getting from traditional software composition analysis scanning that is looking at CVEs. Okay, so let's talk about software composition analysis. This is the part of the picture here that's going to examine your open source packages. Folks here, I'm sure, are familiar with the Log4Shell event. This would be the kind of tooling that helps you uncover where in our organization are we using a particular version of Log4j. You can see here that we're covering a range of package managers and ecosystems today, including Java, Kotlin, JavaScript, TypeScript, Python, etc. We're going to get a little more into the product roadmap next week and the road ahead there, so please do sign up for that if you're a customer of Sonar's today. So the key use cases for us that we're focused on right now are the ones you see here. From a vulnerability management perspective, we want to ensure that we are empowering developers to start as left as possible with information that helps them remediate, remove, patch vulnerabilities in their direct and transitive graphs as quickly as possible. So the direct vulnerabilities or direct packages are things that your developers have chosen to bring into your application, but oftentimes those vulnerabilities can bring in very large, sprawling dependency graphs underneath them. It's important that you have the full depth, the full chain to analyze and empower your devs on. The SBOM use case is a little bit more of a managerial use case. This is a way that we create an inventory for your company to be able to quickly assess and understand everything that's going into your applications, from the package name to the version, how it's coming in, and also what is the validated license that's associated with it. On the quality gate side, this is sort of core to how the product works here at Sonar. This is the quality gate that prevents any new dependency issues from entering your code base. I love the way that this paradigm was already here in Sonarqube as we came in with our SCA data and value. So we'll get a little more into that into the demo, but this is something really important for developer experience. And then finally, we have the open source licensing management use case. This is, again, highly connected to the software bill of materials or the SBOM. But we're also giving you the capability to both configure and enforce licensing policies. And you can do this both globally, or you can assign a subset of projects to follow a specific license or licensing policy. This is really helpful when you potentially have something like a mobile app development team in your organization, or you have a team that's focusing on software that's going to be distributed. You're going to have a different set of open source licensing criteria that you want to follow versus a team that may focus on internal applications that are built for developers in-house, or something that is more of a server app, for example, that wouldn't be distributed. Something really wonderful about the way that we built this at Tidelift and now we've brought into Sonar is we actually partner with and pay open source maintainers to implement secure software development practices right from the start. So this is very resonant with the start left framing that Manish covered earlier. We take this to an extreme here. We actually are partnering and have business contractual relationships with the developers behind many of the common open source packages. And that delivers a lot of powerful results for our customers. What that means is we're going to have better dependency lifecycle resilience. You're going to have fewer end of life or abandoned packages and the associated operational costs when that happens. Went through a body of research last year looking at what is the real cost to an organization when a package or the packages going into a framework end up abandoned. And it's quite significant to rip and replace a package and all of the work that goes in across development and legal and compliance and security. It actually becomes quite expensive. These maintainer relationships also give us a deeper vulnerability review, which I'm going to demo to you in a moment. And this is critical for saving development time and costs. And then finally, there's just, again, these contractual practices in place that reduce a broader range of software supply chain attack types. We have different examples of this where having multi-factor authentication or specific build practice, something that could have been a pretty catastrophic event from happening. All right, I'm going to click over to give us a demo now. And there's also a link here that we'll be sharing after the presentation here today, where you could actually go and do an interactive demo yourself. I'm really excited about what Manish and his team have been doing over there. Okay, so what I'm sharing on my screen now is the sort of home project view of Sonarqube Server Enterprise Edition. This will be familiar to folks on the call. And what you're seeing here is a specific Java web app that's been analyzed 6 days ago. When I go into this app, I'm able to see now there are some dependency risks, and there's also a set of dependencies under this inventory tab. What I mentioned earlier about developer experience that's so critical is for this particular project, the dependency risks that you're going to see here on the main branch are 43 risks and 57 dependencies. What we see on a pull request branch is that there's a very focused view for your developer on the new dependencies and new risks that they themselves brought in. This makes this much more manageable for a developer to proactively address risks in the moment. they're getting, again, just really focused information on their PR and their PR decoration, and they can go from there. So I'm going to tick back over to main for the purposes of this walkthrough. And I want to go into the detail of this particular Jackson data bind package to walk through developer experience here. What we're going to show your developers is the software quality that's impacted, the risk severity, when it was first detected, and developers have the ability to assign work. The way that we're calculating risk severity is actually a combination of a couple of data points. We are not just using CVSS score, which in general is a marker of a certain type of risk. We're also bringing in the CISA known exploited vulnerability list. That's going to include things like particular releases of log4j. And we're also bringing in the exploit prediction scoring system, which is the likelihood of this being exploited over the next 30 days. This can really help developers focus their attention on what is the most urgent thing that they should focus on. And it's a better indicator than CVSS score alone. Oftentimes, something may have a high CVSS score, but the risk there may not actually be that great for developers. And so we really want to continue to focus their attention on the most urgent items. As a developer, I can come in here and change the status. This may be something that's going to take us a while as a team to take care of. And so I may want to confirm that it's valid. I can add a note with some traceability around maybe a JIRA ticket as an example, or other notes to myself if I come back to this in a sprint or two, or maybe even next quarter. This can also be a great source of information for compliance and security teams to track what's happening in the life cycle of this particular vulnerability. We give developers information about what the risk is, and then we give them how they can fix it. In this particular example, the affected version is 2.9.10.7. The complete fix for this, the latest safe release, in other words, is going to be 2.19.1. We do actually give developers a kind of stepwise motion to see other releases that may have a partial or complete fix. The jump here from 2.9 to 2.19 is not huge. Knock on wood that this would successfully, be able to be patched and the developer could move on. But in the event that this was, potentially hopping 1 to 5 major versions ahead, that's a much bigger undertaking for a developer. And so if there's a closer fix that can get them out of the really risky zone, we want to make sure that they have that information. They'll also be able to see the activity here as well of what's happening. So another thing that's been very critical for developers making progress here is to ensure that they can see how is this dependency introduced. So when a developer clicks into this view, they'll be able to see the full dependency graph. In this case, this is a direct dependency, so there's just one way that this is coming in. If I pull up a transitive dependency here using my filtering criteria off to the left, I can see an example where the dependency is being introduced through this chain. This is only one level deep, so not a huge burden on a developer to go figure this out. But in the case of many frameworks across Java, certainly Node, other ecosystems, these dependency chains can be very intricate and long and sprawling. Packages can be brought in multiple ways. So this kind of information, again, really helps developers shortcut their time and effort and gets things taken out of the application more quickly. I'm going to reset this filter and show you one more piece of information here. These insights from the maintainer, again, this is a particular package where Sonar has a relationship in place with this maintainer. And even though this has been identified as a high risk, and we're using, again, our numeric criteria to find that, we've still got the likelihood of being affected from the maintainer themselves, and we've got different information about different classes or functionality that's affected, any workarounds that may have been available, and then other conditions to check into. So in many cases, this is going to be pretty extensive information where the maintainer is providing much more partnership and much more sort of on the ground information about how a vulnerability applies. This can, again, help shortcut research time and remediation time. I'm going to click over quickly to our inventory and our dependencies here. This is a list that is really helpful for, again, quickly searching for log4j as an example. Where am I using this? You can see here we're also pulling in the licensing. We have an extensive licensing research process that's going to do a deep dive into the repository and into the package files and ensure that we're bringing the correct SPDX formatted normalized license. You can also export an SBOM here in the common machine readable formats, and this is available also via API. I should mention that in order to get this kind of analysis, you do need to do a little bit of setup, and I'm going to show you that quickly. Under administration, you'll come into advanced security, and once you have the license settled to access these capabilities, you will tick this box to enable SCA. There will be a quick connectivity check for internet connectivity, and then you are off to the races. Anywhere that you've already installed Sonarqube into your CI/CD pipelines, in your PR processes, it will automatically start running this powerful analysis. You do need to do at least one build of the project, of the application, to get the analysis on the project. But in terms of operational overhead and time to value, this is pretty exciting. So I mentioned developers are going to get this information on their pull requests. The way that we do that is, of course, through quality gates and licensing profiles. Under a licensing profile, you can create a new one. And what that will allow me to do is actually use a few out-of-the-box templates that we're providing on things that go, we've already categorized licenses in terms of being permissive. This is your MIT Apache licensing, things that are strong copyleft, the GPLs that a lot of customers want to stay away from, and a few other categories here. So if I go ahead and apply this policy, what it's done is it's going to go ahead and categorize many of these licenses for me. I can also come in here and override this decision. If I decide that this is not compliant with how our organization thinks about risk, I can say, actually, I want to prohibit this one. And it will inform me that the default was allowed, but I've made the decision to override that. Again, I can choose to apply this globally, or I can also apply it to a certain set of projects. In this case, I would do that. And now it's applied to that project. From a quality gate perspective, again, familiar interface for those on the call that are Sonarqube customers. If I want to go through here, I unlock my editing, and then I add a condition. I would choose to personally to set this up both on new code and another one on overall code. For our new code, we're going to do dependency risks, and you can choose to look at severity across the board for all dependency risks, or you can choose to have some distinction of licensing versus vulnerability risk. For licensing risk, if something is out of policy, it's considered high. It's more of a binary type risk. A lot of customers that we've worked with in the past and continue to work with today would choose to begin with a more graduated approach. So they'll start with vulnerability risk. They'll start with things that are high critical blocker type risks before they begin rolling out more vulnerability conditions or even additional licensing conditions. All right, so all of this is going to help keep our customers safe. It's going to ensure that developers have this information in the workflow they're already used to using. It's going to continue to enhance our ability to support security that our customers need. And we're going to be continuing to grow. Again, the value here in advanced security. One thing I want to mention, I think we had a question earlier about internet connectivity. We're going to share the link to the public documentation on this. But there is information here about the internet connection and also what data are we collecting, because we know that's important to our customers as well. But there's lots of great stuff in here around package managers that we support and ensuring that the environment is set up well for great analysis outcomes. All right, so we're going to do another poll here. We've got quite a few long sentences here, but this is super helpful information for the product team as we think about how we prioritize our roadmap ahead. We're really interested in understanding what are the biggest challenges for you all with dependency lifecycle management today. I'm seeing results coming in. Ooh, a lot of these are very head-to-head on what is the top one. It does look like staying current on dependencies is a challenge. Certainly, having too many things to take action on and that prioritization problem. And then a little bit more about developer hesitation on breaking changes.
Yeah. Prioritizing multiple high severity issues is high up there in terms of responses. And this is exactly how we are thinking about it. Surfacing real issues, helping you prioritize, helping you discover them as early as possible. That's our core philosophy. And it's not just about security issues. We help you discover both quality as well as security issues, because the two are go hand in hand. They are inseparable. I apologize, we didn't share one of the earlier results, but here I shared this one. So that was a mistake on our part that we didn't share one of the poll results. This one I've shared it, so you can see how others are responding to it.
Thank you. All right. Let's see.
You want to wrap it up, Lauren?
Yeah, or you can take it, Manish, sure.
It's either way is fine. Okay. I think we have got lots and lots of questions in the Zoom, which is very good. I'm glad you are keen to learn, and that is the exact intent of these webinars, to help you learn about new capabilities, not basically sell you anything, but learn and become more educated about what's happening, what we are doing, and how you can get more value from the products that you already have and use, right? To end the webinar, and then we can take a few live questions since we have a few minutes left. We are providing you with an integrated solution. And by that, I mean it's a unified solution that goes beyond security issues. It gives you insights into reliability issues, maintainability issues, secrets detection, security issues, now with advanced security, open source libraries. And we are also soon we have actually started adding rules for architecture analysis. So architecture as code is something that we are investing in, which is going to become a big deal once AI starts writing more and more code. You want to make sure the architecture of a code is not drifting too quickly, too fast, and becoming a bad architecture. So we are adding architecture rules, and we are adding design and architecture capability in our upcoming release. So we look at it as an integrated platform that provides you comprehensive coverage for first-party AI-generated code as well as third-party libraries, and all using the same workflow that you're used to with Sonarqube. So you don't have to have multiple tools, multiple separate workflows. It is part of the single workflow from IDE to CI/CD as part of your PR analysis and branch analysis. We also strongly believe that it's a developer-led security world. Developers should fix the issues as and when they arise. Catching them early, as we saw with a couple of examples that we shared, helps you save a lot of heartache and pain down the road. Right, you don't have to respond to pagers and night out work on weekends to solve firefighting issues. If you do firefighting, if you can catch them early and catch them as part of your developer workflow. Next is, I think we are also heavily focused in terms of not only the breadth of coverage in terms of the 35 plus languages that we support, but also how deep we can go in terms of accuracy, in terms of speed, in terms of detection. Can we extended our accuracy depth by adding advanced SAST, which is basically going deeper into the code level, deeper and deeper. So SAST tools, if they discover 10 issues, we might discover one additional issue with our advanced SAST, which is the 11th issue. And every additional issue that you detect is basically a security problem that you've saved from becoming a big problem. And then last, the results that we show you, we want to focus on true positives and minimize the false positives for you, and give you remediation guidance via AI code fix and the agentic capabilities that we are adding in the product very soon. So it's basically, our aim is to help you build software better and faster, and have less problems down the road when you actually running the application and in your operations in the ops phase of your life cycle.
Manish, I'm wondering whether we should cut there because we've got so many questions. We want to try and answer at least a
Sure,
couple live.
sure,
So,
sure. Go ahead, ask the questions.
yeah. So let's dive in quickly. So, I'm interested in the new feature, discovery and analysis of dependency risks across multiple applications and portfolios. Can Sonarqube be configured to use internal Artifactory to detect dependency risks, or does it need access to Maven Central, PyPI over the internet, etc.?
I can take this one. So we can absolutely be configured to point at an Artifactory instance. We will still need internet connectivity, which I mentioned, to reach both the upstream package repos for correlation on package data, but then also vulnerability data. So what will happen in analysis in that type of environment is any internal packages that you may have or forks of upstream packages will be just simply marked as unknown for today. And then anything that does correlate with that upstream package, we will provide the version license, et cetera, information on that.
Thanks, Lauren. Next question. Do the custom configurations require developing theses in Java, or is it just about defining additional configuration files?
Sorry, can you, are you taking that, Lauren?
No, I was going to say, I think this is about the custom security configuration engine that you mentioned earlier.
Yeah, I think so.
Yeah, can you say that again? I didn't quite.
Yeah, the custom secrets, I suspect, is what's being asked about. Is it about defining additional config files, or how would you go about doing that?
Yeah, so for custom secrets, no, it's not about defining custom config files. It's basically using rules and regex to add your custom patterns. That's how it is. But thanks for asking that question. We are looking at to making it easier than just defining a configuration file and making the, investing and making it easier for you to use rather than writing a regex or do something more, which takes a little more time. So yes.
And apologies if that isn't quite the intent of the question. Please put it in again and we will refine our answer. Let me see. Does the Advanced SAST add-on mean more rules and security hotspots than the core SAST in the Enterprise Edition?
Yes. So basically, Advanced SAST is something that will help you discover an additional issue or two. It's not like you will discover 100 new issues, right? It's about catching that one extra deeply hidden issue, which could not be caught because SAST typically only analyzes first-party code. It analyzes code that you are writing or AI is writing as part of your first-party code. It does not have visibility into the libraries and open source code and the frameworks that you're using and how you're invoking those frameworks. If you're making a call into an open source library from your first-party code, how that call is made and whether that results in a security call is what we detect with Advanced SAST. So it's not about quantity of issues, but it is more about finding that deeply hidden extra issue which most traditional SAST applications cannot discover.
Got it. And I'm going fast, so apologies. There were a few questions around availability of advanced security, and they can be summarized as: are they available? Is it available in the latest LTA of Sonarqube Server? Is it available in Sonarqube Cloud? We're on the legacy paid plan of Sonarqube Cloud. Can we have access to this? You can probably summarize some of the answers there, Manish or Lauren.
Yeah. So core security capabilities are available with Developer Edition, Enterprise Edition, and all the editions that you have, all of the commercial editions. Security custom configuration and custom rules is Enterprise Edition and higher. Advanced Security is an add-on pack which extends first-party code security to third-party open source code. That is an add-on license that can be applied on top of Enterprise Edition and higher. It was released with 2025.3 server release, which is just 4 weeks back. So it is available on 2025.3 and higher. It will be coming to Sonarqube Cloud very soon, hopefully within in Q3. So we will have that available for cloud as well. I hope that answers all the questions. But if you have any other questions, feel free to reach out to us, and we'll be happy to take them offline or post them in the Q&A section and we'll share the responses.
I'm going to squeeze in one more question real quick. Is SCA available retroactively?
No.
Oh, I can take this.
Yeah.
Well, so once you start using the service, then it starts from that moment forward. So I can see the question here in the Q&A box. What you're asking about, Kevin, is do you have to continuously rebuild the app to get the analysis? You do not have to do that. Today, the way that we advise customers to navigate this challenge is to configure their build pipeline to do an automatic analysis, potentially overnight in the background. But in the next release of Server 2025.4, we will have a turnkey solution for this because we've heard from customers like you that this is really important. So
thanks, Lauren.
Coming very soon.
Yeah, thanks for letting us squeeze that final question in. And thanks both Manish and Lauren and everybody who submitted questions. We had lots. Apologies if we couldn't answer them all live, but our community forum is a great place to ask further questions and also find other responses to people who've already posed those questions. If you're a current Sonarqube server customer, we do invite you to attend session 2 next week, the customer deep dive into advanced security, where we'll take an in-depth look. If you haven't registered yet, a sign-up link will be included in the follow-up email for this webinar. And if you did have any unanswered questions from today, take them to that session and we'll try and address them for you there. Finally, taking a deep breath, thank you for completing the survey that will appear shortly. We appreciate your time and your feedback. So thank you to everybody and see you next week. Goodbye.